Right. So last topic was NAT, and I'm just starting with a very quick recap of the previous session that we had. And straight away, then I will take you to this lab like scenario, in fact, lab topology, and we'll see like how to configure NAT in Fortigate firewall. So we talked about like NAT implementation in Fortigate firewall. So there are there are two different types of NAT or major NAT types. One is source NAT, wherein source address, like either source IP or source port address, is translated, and further then in source NAT, like there are multiple options. And another type of NAT here is destination NAT, wherein destination IP or destination port address are translated. And there are two different ways to configure NAT in FortiGate. One is like firewall policy NAT, means like uh, we enable NAT in the security rules, security policy itself. And there is another way of NAT configuration in FortiGate, that is central NAT. So in central NAT, basically a separate policy for the NAT is created. So central NAT is similar to the NAT configuration that we do in other firewalls. And mainly central NAT is for migration and for some other purposes here. So we can use like either firewall or central NAT. Most of the options would remain same. So like types of NAT and even translation types very like identical, same. And in further in statics in source NAT, in fact, there are uh, different types in source NAT under source NAT section. One known as static SNAT, static SNAT. Generally, we call it like port address translation, many to one translation. Many internal IPs are mapped or translated with single IP address, many to one translation. That is static SNAT. And total 60,416 ports are available and can be used in the NAT translation. That means with single public IP, there can be 60,416 concurrent translations. So if we want more than that, if let's say we want like somewhere around like 90,000, 95,000 concurrent translations, so we cannot use many to one translation. Then many to many translation means internal IPs mapped with pool of external IPs or NAT IPs, maybe 2, 4, or 6 IPs. So this way, number of concurrent translation increase would get increased. But by default, in FortiGate firewall, outgoing interface IP is used in NAT translation by default. Means many to one translation, and internal IPs are translated with firewall external interface IP. But yes, can be changed because a lot of engineers do not prefer to use firewall interface IP in any translation, in fact, right? So if there is extra IPs are like provided by your service provider, internet authorities, so even you can use those IPs in your NAT translation instead of using firewall interface IP. And that's what here overload and overload option is basically. So overload is basically many to many translation and even can be many to one translation also. But other than firewall interface IP, of course. So overload is again very similar to the same like PAT plus dynamic NAT in Cisco, like many to many translation. One to one again, like uh, IPs are statically mapped. So if let's say we have total 50 internal IPs and there are 50 external IPs, then we can configure this one-to-one translation type. IPs mapped with one IP mapped with another IP kind of thing. And then the two more options we have in Fortinet and fixed port range and port block allocation. Again, here, like we mentioned, we specify uh, internal IPs, like how many internal IPs we have. Let us assume 100 IPs. External maybe only 2 IPs, right? So internally, port numbers are calculated, like the port range. In fact, that port number maybe like 10,001 to 11,000 or 12,000 port numbers would be allocated to one internal IP. Rest of the port maybe another, then another. So and very similar to fixed port range, we have another option, port block location. And here we mention, like if per user there should be 8 blocks and each block can have 128 or maybe 256. Is configurable. By default is 128. So 128 ports in each block. And if we assign 8 blocks per IP or per user, that means for single IP, there would be a total number of ports like 1024, I believe. Whatever like value comes, multiply 128 with it. So it's something like a reservation kind of thing, like that. We have reserved port numbers per IP address basis, right? So that like every one each IP should have equal number of translation entries. So it's all about like the port allocation, port management. So this way, like total, we have 4 options for the in dynamic SNAT. So overload, as I mentioned, like is like many to one translation, or can be many to many also. One to one is like internal IP address and external IP address statically mapped, and port translation is not done. So this is one of the main difference. Like in static one to one, there is no port address translation. IP is statically mapped with another IP address. So you don't, and that is why if there are 4 external IPs, so only 4 internal IPs can utilize NAT translation, because it's one-to-one mapping, in fact. So this one-to-one is can be used wherein like you don't want port address translation to be the, you want to strictly preserve port address translation. So in that scenario, you can use one-to-one. And fixed port range, as I mentioned, like uh, with this, like if we mention private IPs or internal IPs, also external IPs, so Fortigate firewall automatically computes or calculate the port range that can be allocated or assigned or used per IP address. And in port block allocation is a proper reservation. In fact, we can reserve that for each IP there should be 1,000 ports or maybe 2,000 ports, like this. So 1,000 or 2,000 port numbers reserved for each IP, so that there should be equal distribution of port numbers. So it's all like different options and in FortiGate firewall total. And here is the example. And then we have destination NAT. With destination NAT, we can translate both destination IP and as well as destination port address. Both can be translated. Even we can also do port forwarding, that if request hits on port 8080 port number, then that should be translated to port 80. And also we have a separate feature here, virtual server load balance, but it's a very separate feature. And as we all know, in load balancing also destination NAT or maybe source NAT, both are done and supported. By default, destination NAT is enabled in most of the load balancer. So Uh, but it's a separate concept. In fact, virtual server load balance in Fortigate also there is separate service for load balancing, and basic functionality of a load balancer, yes, is there in Fortigate firewall, but not the advanced functionality like in F5. Like we create I rule, a kind of a script for some advanced load balancing methods. And there are too many settings, in fact, compression and a lot of optimization features. Uh, but in Fortigate, we have very limited functionality because Fortigate is primarily a firewall, not a load balancer. But at least if you want basic load balancing mechanism in Fortigate, like round robin kind of thing, health monitoring, of course, then yes, you can use this virtual server load balance option in Fortigate firewall. But it's a separate. So source NAT and destination NAT. In destination NAT, there is no complexity. But in source NAT, since there are multiple options, so yes, it's a bit confusing. In source NAT, in fact, not in destination. And central SNAT is again same like um, in central SNAT also there is one-to-one overloading and all the options like whatever we have discussed. But the way like how NAT is enabled is different. So that's what like central SNAT is. And only the source NAT portion. Destination NAT is same. No matter whether you are using policy style or central NAT style, destination NAT, this one is same. But yes, source NAT option different because in central SNAT, we create separate policy for NAT and firewall policy separate. But by default, central SNAT is disabled, can be enabled if required. Otherwise, even you can use NAT in policy itself. All right, so already we have discussed in detail about NAT and all that. So we have a very small lab topology here, and let me explain. Management IP 10.1.1.101, and I think only interfaces are configured. All the three interfaces: management, external, and internal. But as so there is no policy created. So we are going to first start with source NAT. And in source NAT, we'll see like different options. Static source NAT, we use the term like PAT for that. But in Fortinet, like Fortinet, call it like source static NAT. And source or static source NAT, basically, rather static source NAT. Then we'll see like one-to-one option, overloading option, reservation or port block allocation option from where we can configure. So if I just show you the GUI page of this firewall. So there is no firewall policy already created here. So implicit, of course, implicit means default policy like source any, destination any, and action is denied. And interface is already configured. So if you look at this network interfaces, so both interfaces, LAN and WAN plus management configured. So port 2 is the LAN 172.16.1.101, management port 10.1.1.101, and then port 3 is the WAN port 1 and 2 168.101. So three interfaces configured, and there is one default static route here. So there is one static route already created. Any network address, any subnet mask, and next hop is gateway 192.168.1.1. So firewall has like a default static route, interfaces are configured, but also there is no policy. So first, I'm going to show you how to configure NAT in each policy, in fact, policy style NAT configuration, not the central NAT. And even you don't see any option here like central NAT or something on left hand side. So under policy and object section, we don't see any central NAT option here because central NAT is by default, central SNAT rather. Central SNAT is by default disabled in Fortigate firewall. not visible here. So click firewall policy, create new, and I'm creating a policy from LAN to WAN or LAN to internet. You can give any name, no worries. Outbound traffic. Incoming interface. So port 2 is the incoming interface. I'll select port 2. Outgoing, of course, WAN port. Source IP. So any IP in policy, I'm going to use this the entire subnet, in fact, 172.16.1.4, 1.3, 1.2, 1, all 254 IPs, right? So instead of like any source, I'm going to mention a specific subnet address, right? So for that, what you can do, you can create a new object here, new object. So network object, I will use the term LAN, and in the object address itself, if I'm allowed to use slash, and in Fortigate, I believe we can use slash in like anywhere in the name. In other firewalls, slash is not allowed. And IP and mask is just the name. It's just the name, in fact. Actual subnet and mask is specified here. So object is created. Double click.
Can you go back? I'm sorry. I have a
Yes.
question here when you set up interfaces.
This one?
No. Can you go back previous slide one more time? When you create object?
Okay, object. Okay, sure. So here, like create.
Yeah, which is previous slide. You create object. You were creating object. There we go. The interface. What does that any mean?
Even we can specify like this address where like this source address is like reside or resting in. I mean, like if we have specified, however, there is no point of like using multiple times, like already we have mentioned here, and that is why I ignored that. But that's really very good feature, and to prevent IP spoofing or any other attack similar to that, because if I have said like source address 172.16.1.0, and if I have also specified that the source address or network address, this should be here only, maybe in somewhere like reachable via port 1 or port 2. That means if uh, the same source IP address hitting to any other interface of the FortiGate firewall, so this is null and void, means like will not match with the policy. So specifying interface also means with the source object means like if we have a FortiGate firewall and address object, let's say I specify 1.0 and interface port 1. That means our port 2. So we have specified that this network address is reachable via this port, means where this network address is. I mean, like where uh, connected with port 1, connected with port 2, connected with port 3, or connected with port 4. And it's one of the matching criteria also. But why I ignored that? Because already I have specified here like incoming and outgoing interface. Incoming interface should be port 2 and outgoing interface should be port 3 only. So even if, uh, let's just assume with any tweak or spoofing or any other reason, let's just assume that a packet, any request packet hits external interface of the firewall, external interface in this lab topology, port 3, and sender claim that my IP address is from the LAN segment. That means my IP address is 172.16. Let us assume 1.90. So firewall is immediately going to discard this request packet. Why? Because firewall will match both, like source IP address, of course, should be from this range, and also the incoming interface. So if the source IP address is matching with the rule, source IP address, let us assume is like 172.16.1.1, and you understand this would happen only if some invasive or any other like tactics have been used, because without any third party software or IP spoofing or something, not possible, because 172.16.1 is my LAN network, in fact. So not possible at all, like packet hitting external interface and source IP address is from the LAN segment. But if already we have specified here incoming interface and here just the address, so this is going to work. Like it's a perfect, I mean, like will prevent IP spoofing attack. It's very much like anti-IP spoofing. But since once object is created, then you can use object at several places in different policies. In fact, not necessarily we use object here only. Once you have created object, then the same object you can use in different policies also, be that IPv4 DOS policy or maybe some virtual wire policy or some other policy. So because if we go to this section, address section, so we'll see like this object created, and object can be used multiple times in different policies. So it's very specific, like creating object with interface means like we are very specific that this network address reachable are connected with this interface. But why I ignored that? Because already in my policy, incoming interface is also specified. If in any firewall, let us assume we create policy without specifying interface or zone, right? Without specifying interface or zone. So yes, there can be IP spoofing attack then, right? Because if you have not specified incoming interface or security zone, only the address. So with the any tweak or maybe manipulating, playing around the source IP address, easily the packet can get through the firewall, and even firewall can uh, assume as if packet is coming from the internal network side, trusted network, or maybe the private network. So to avoid that, like Fortigate has introduced like incoming and outgoing interface option in the policy itself, and also even at the time of creating object. Make sense, Derek?
Yep, I got it. Thank you.
Okay. So there's no worry here because we have already specified incoming and outgoing interface, but not in all firewalls. In fact, you see like the lot of firewalls wherein like we do not mention or specify incoming and outgoing interface, only the source and destination address. But in those firewalls, like we do some extra configuration then, like in checkpoint. Uh, uh, like when we configure interfaces, then we enable NT-IP spoofing option there. So a separate feature, separate mechanism. But Fortigate is really very easy, very simple. We don't have to enable or disable NT-IP spoofing from anywhere, and even we don't have like that setting also in Fortigate. So really, I like this feature, incoming and outgoing interface, to avoid any kind of IP spoofing. So moving on to the next one, and next one is destination. So of course, destination, like we don't have to create any object for the destination because destination is internet. So that means all. And schedule always, yes, you can create time specific if you want to allow web browsing traffic during business hours. So yes, you can create rule for a specific length of time, days, right? Time, you can include both. It's very much like creating time-based access list in Cisco devices. And how we do this? So if you go here, so again, we have the option to create a time object, schedule kind of thing, right? So if you click here, create, then option will pop up here, and you can like still it's going on, so it's getting slow. And this way, like we can create object here already. I can see like which type of object we want to create, like one time, recurring, or you want to group this. So this way, like one time are recurring. So you can specify days and time. So this rule would be active for a specific length of time. Action is accept and flow based. Yes, I want to go with it. And here is the option that we want to discuss today. NAT option. So basically NAT is what? This section is about source NAT, SNAT, source NAT, right? And in source NAT, the default option is source static source NAT in Fortigate term. In our term, in fact, it is PAT, basically nothing else. Many to one translation. Many to one translation means, and many to one, and with interface IP means internal IPs translated with firewall external interface IP. So source IP, any IP address from this range. Source IP, any IP address from 172.16.1 translated to 1.101. Firewall exit interface IP. Right? If you want to use other IP other than like the interface IP, then yes, we can configure that also. But default is firewall interface, and it's a many to one translation. So here, even if I have 200 computers, 200 IPs, there is only one public IP address. No worries. It's absolutely fine. 200 is to 1, or maybe 1000 is to 1. Depends like how many concurrent connections supported here in PAD. Obviously, 60,400 something like ports are available. So number of translation can never exceed 60,400 connections, right? We're not talking about number of client machines or IPs, because a single IP can have 30, 40, or 60 translations, right, in the firewall NAT table. So if we want to go with the default one, default that is many to one translation, and let's quickly see this and then we'll discuss other option. So, and I want to log all sessions, not only the security events, all sessions for the logging purpose, and policy is enabled. That's fine. Just hit down. Okay. And what is missing here? Service. What service we want to allow? So let's say I want to allow web browsing, or maybe all service, no worries, even ping and all that, all services, right? And service means service ports. So all TCP, UDP, ICMP, all allowed. ICMP is also allowed, right? But let me discuss one important point. ICMP is also allowed. So in service, like we have specified all services. So be that TCP based any application, UDP based application, ICMP based application, or any other protocol. And in port address translation, what happens? Like is my Fortigate firewall or any other firewall. So whenever we configure PAT or overloading or port address translation or this source NAT with many to one translation, right? So what happens? Source IP address and source port address both are translated, right? Source IP and source port address both are translated. If we want to preserve source port address, so in some like devices, appliances, we find option to enable that, like preserve port number, but this would reduce number of translations or concurrent connections. To make any connection or translation unique, both source IP is strictly translated and source port address optional. If like connection is a translation is already unique, so generally firewall ignores or skips doing port translation. But if translation is not unique already there is one entry in the NAT table with the same port number and same IP address, then immediately firewall translate port address also. So what we understand in many to one translation, both source IP and source port address both are translated. So whenever there is any TCP or UDP based application, so we understand TCP or UDP based means TCP protocol, and then the upper layer data and IP header also. For UDP based traffic, UDP header, data, and IP. Right. This is what TCP based, and this one is any UDP based application. So in TCP and UDP based application, there will be a source port, destination port, apart from other attributes in the TCP or UDP header. Right. So if we look at the TCP and UDP header, so definitely we find source port address, destination port address. In case of TCP, even like flag and the initial sequence number and some other attributes. Right. IP header we understand like source destination IP and too many other attributes like TTL, checksum, protocol number, DF bit, right? DSCP marking and so many like attributes. There are 20 bytes in fact. But what about the ICMP packet? So if I initiate any ping from here, this computer, and port address translation is in place, configured port address in translation. But ICMP means what? IP and directly encapsulated here. ICMP is encapsulated inside IP header. There is no TCP, there is no UDP header, right? There is no TCP and there is no UDP header. So the question here, the big question here, uh, is like how do firewalls handle port address translation with ICMP packets? Because I hope you all understand like the point here, what point I want to make here means your ICMP packet, any packet like very like, for example, ping, right? So in ping, ICMP is used, not TCP or UDP base. There is no port number because there is no TCP or UDP header, right? So the question here, how do like firewalls deal with ICMP packets in terms of port address translation? Because what we understand in port address translation, both uh, your what do you call it like source IP and source port address, both are translated. So if both are translated, then just like there is issue. So any idea like how firewall will be dealing with like this ICMP packet, because there is no like port number here in ICMP.
No, sir.
No idea.
No.
Derek, have you ever thought of this?
No, not at all. Good question.
Because there is no like in fact I'm not sure whether my Wireshark is running or not. It was giving some issue. But if I can show you, let's say if it is working. There is some issue with my interface, I think. Just a minute. It says I said sometime. When interface is specified, but because of some reason it's not working, so no worries. So basically what happens in ICMP, if you ever looked at ICMP header, then in ICMP header, um, like total 8 bytes, of course. So we see like type and code, and also like sequence number there in ICMP. So uh, in ICMP header itself, like type and code is only used for message type, like whether equal reply or destination host unreachable, destination net unreachable. So for some error reporting, like there is type and code field, and there is like sequence number field also there, and just and luckily like equal to the same port number. So basically this number sequence number is treated as the port number by most of the NAT devices. So whenever they perform NAT, so they just look at this ICMP header, and unfortunately my Wireshark is not opening up. So maybe in the next class I will fix that, and I will show you like this complete header, like ICMP header. I will explain like what exactly type here is in ICMP header, code, because there are total 255 types, I believe. Type 0, 1, 2, 3, 4, and different code, in fact. Like because sometimes we see destination net unreachable, destination host unreachable, port unreachable, this, that. So just because of different code and of different type, and also like we find there like a sequence number field in ICMP, and that is treated as the port numbers by most of the firewalls. So they basically replace that. In fact, they understand like that is something your port number. So a unique serial number is treated as the port number. In fact, so NAT is done with ICMP packets also. Not only NAT, PAT is done, even though like port number is not present, port number is absent, there is no port number, but because of that ICMP header structure, sequence number, the very important attribute in ICMP header, NAT devices, yes, successfully they translate ICMP message also. Maybe in next class, if Wireshark will be running, then I will show you practically, then that would become more relevant to all of you. But unfortunately, Wireshark is not running. But anyway, uh, this happens like, I mean, like source IP and source port address both are translated, and how we can do verification. So let me quickly go to any machine, maybe here like 172.16.1.2, and I'm going to initiate traffic through the firewall so that we can do a quick verification here. So it's an internal computer. Let me open Facebook or any other uh, destination. So have been working. Let's see what happens here. Set as default. And also, yes, it's working. It's not very quick, not very fast, but I can see now Facebook page is getting loaded. But before, also check CP8 or CPL IP configuration. So let me also check the IP configuration. Is that correct or not? IP should be any IP address from 172.16, and gateway 172.16.1.101. So 101 should be gateway address. We can also initiate like ping traffic from this computer, or there are two other routers in the LAN segment. So we can initiate ping traffic also from the computer. So 1.101, correct. So IP is properly configured, and yes, like Twitter and Facebook open, loaded up, and also I can initiate ping from R1 and R2. So if I initiate ping 888, should be working. If like there is gateway, yes, it's working. Send packets. Enable mode first, then we can run ping 888, repeat 200. All right, from here, R2, if I initiate telnet to any destination over the internet, and if telnet is allowed, then yes, we have successfully connected. So telnet, ping, HTTP, DNS, all working. Translation, how we can verify that. So the best place to check that, in fact, is go to dashboard, and at the bottom, 4D view session from graphical user interface mode, GUI mode. So 4D view session is showing up all the session and source IP 1.2 router IP, and translated to, where is the translation? So let me adjust the column: source, destination, application, port, bytes, packet, duration, destination interface, source NAT address, source NAT port, and destination. Do we have to? So you can like disable or enable different columns from here. Apply this. So source IP 172.16.1.2, and where is the translated address here? So let me drag and drop so that we can see at the front, right? So maybe here also just, okay, all good now. So now we can easily map. So source IP 1.2 mapped with 101, 1.3 mapped with 101, same IP address, of course, so single IP. So different destination, but mapped with same IP. And in ICMP, you can see here source NAT port. A port number is showing, but exactly it's not a port number or sequence number. In fact, in ICMP header, I'll show you like ICMP header with the Varsha capture, maybe in the next class. So we see here like port number, and like here 8, and this one is 53. 53 is the UDP port number, like DNS, right? Then UDP port 443, and UDP port 53, GCP port 443. So basically, in ICMP, echo request packet is basically your ICMP type 8, and there is a code, port 0, and reply packet has type 0 and port 0. So type and code are also two important attributes or fields in ICMP header. So it's sometimes becomes confusing, like what is like type, code in ICMP, and what's the exact meaning of that. And you must have seen like a lot of time, like we see destination network unreachable, or destination host unreachable, destination port unreachable. Sometimes ICMP redirect message in some, you know, like what do you call it? In VPN, in fact, in Cisco also, DM VPN, dynamic multi-point VPN. So in DM VPN, even ICMP, NHRP redirect is used. So similar ICMP redirect is another redirect message. And whenever like there are extra hops, so to avoid that, internally ICMP redirect messages are used. So there are different message types. So for that reason, like there are different types and codes in ICMP. So it's a bit different than TCP and UDP. But I can see here like a lot of translation here. And really, if you want to get rid of all the sessions, then simply right click and end all sessions. So all sessions now deleted from here, because we want to change translation type now. I want to go with different option. So I'm back to firewall policy now. And this time, I do not want to use firewall external interface IP in the NAT translation. I want to use other IP, any other IP other than firewall interface IP. I do not want to use my firewall interface IP, right? I don't want, I don't let anybody know like my firewall external interface IP to outside users. So I have planned to use different IP, right? But that IP, yes, definitely should be routable. So in production environment, if you have a different IP pool provided by your internet service provider or authority, so and there is proper routing for those IPs, then you can use those IPs in your NAT translation. You don't have to assign that IP to any interface. In fact, straight away we can use in the NAT policy. And even by default, those IPs also respond to ARP request messages. So you don't have to do any additional configuration, at least in FortiGate firewall. Right. So ARP resolution is also done. So I'm on the same page now, and this time I want to go with this dynamic IP pool option. Dynamic IP pool option, right? So it's asking to create a new pool. Okay, and even a pool can be created from here also. So like if already pools created, then like we'll see here, like already created pools. If no pool created, then yes, we have the option to create new. And also there is no IP pool here. It's blank, in fact, right? So create new IP pool. And now here on this page, there are 4 options. I want to start with overload option first. Overload. And here, if I mention only one IP address, but other than firewall interface IP, means 192.168.1. Let's say I want to start with maybe 120, for example. And dash is a range, but I want to use only one IP. So same IP, starting and ending with the same. Start IP, end IP, same. So it is very much like your PAT translation, right? It's a PAT, in fact. The only difference here is what? This time around, we are not using firewall interface IP in any NAT translation. Instead of using firewall interface IP, we are using 192.168.1.120 IP address. That's the only difference. Otherwise, overload is same as the first option, right? Or if you want to use a range 120 to 121, is many to many translation. Many to many translation. But not static, because maybe internal LAN side, I would have 200 devices, external IPs too. So it's not many to one, it is not 1 to 1, it is many to many. Range of IPs mapped with range of IPs, external IPs. And why it is known as dynamic? Because we never know like which IP address will be used to map which internal IP. This is dynamic, in fact. Maybe here like we have, let's say, 10 IPs. So 10 IPs randomly like mapped with internal IPs. So it's like something increasing number of translation, because if here like there are 2 IPs, 120 and 121, 2 IPs, and if per IP total for approximately 60,400 ports are available. So if we are using 2 IPs, that means number of concurrent connections or translation would be around 120,800. So it's something like dynamic NAT in Cisco. Dynamic NAT, we use the term dynamic NAT. So and I have given the name overload. All right. So 2 NAT IPs and 254 internal IPs. So 254 internal IPs mapped with 2 external IPs. So now select here overload and then head down. Okay, done. And this time if I must have on this, shared some traffic from here. Maybe this computer also. Refresh the page. Refresh. And whenever we do telnet or SSS, so generally we see only one session created, right? One connection. But whenever we open any website from the browser, so we see like too many connections in the table, in the session table, in the NAT table, because whenever you open any website, so in single TCP three-way handshake, all messages are not exchanged, right? So maybe three-way handshake, then HTTP request, HTTP reply, connection is terminated. Then again three-way handshake. Sometimes what happens on the top of single TCP connections, multiple HTTP messages are get and reply messages are exchanged. So whenever we open any website and we check session table or connection table, then generally we see there too many connections, too many translations, right? Happens just because of the reason that HTTP runs on top of TCP, and it's not always 1:1, but many to one. There also, I mean, like with single TCP connection, multiple messages are exchanged, HTTP messages, then connection is terminated. So on single TCP connection, maybe total there are 20 HTTP messages back and forth. Then again a new TCP connection, maybe again 10 or 20 HTTP messages. So this way firewall or load balancer shows or displays maybe 30, 40 or 50 connections for a single website even, right? So you should not get surprised. And even like on some website, we find some external link. Maybe on this website, if there is a link of YouTube video, so another session or connection is created to YouTube, then external connections, all right? So too many connections. So it's not like that I have opened a single website, so why I'm seeing like too many connection in the table. This is behavior of your HTTP protocol. So again, if I go to FortiBoost session, so and see here like too many connections, we cleared that, but you can see here just because of the browsing, in fact, right? In ping, of course, like not too many connections, and even I can see here 120, 120, and some old connections also I can see here, not permanently deleted, but 120 IP I'm seeing here, and source is like 172.16.1.2. Let me generate some ping traffic. See here, like for this ping 888. So 121 you can see here, right? So 121 and 120, like so dynamically used. In fact, we don't have any control over the mapping, but 120 and 121. So this way you can mention a pool of external IPs in your NAT translation. So really, if you do not want to use firewall interface IP, or you want to use a pool of IP, range of IP, external IP for NAT, then yes, you should go with this overload option then. Overload option in the NAT section. And again, I'm back to firewall policy, LAN and internet. Let me show you other options. What other options we have. So get rid of overload, and the next here, like tab is one-to-one. One-to-one. So let me keep name one-to-one. There should not be any confusion. So I'm using the same name. So one-to-one here, like external IP range again, Let's say I want to use 192.168.1 dot, this time 132, 131, 132, 131, two IPs only. And in this lab diagram, total there are 3 devices on the LAN segment, and there are 2 IPs external side. So 1:1 mapping means only 2, and first come first serve basis. Initial 2 connections will be allowed only. So if I have initiated connection with this computer, one IP is used in the translation, this guy, then another one. What about the third connection? No, because only there are 2 external IPs, only 2 internal IPs would be allowed then. One-to-one mapping. Port translation is not done, but it's static mapping, in fact, static mapping. So if we want to check this, so 132, 131, 2 IPs, 30 and 31, hit down OK, and 1-to-1, apply, and clear existing session from here, Fortibu session. So right click, end all sessions. Okay, refresh. Still I can see some session here. So let me close this browser, because browser is still like making some connections. So wait here. End all session. Okay, cool. So all session gone now. So in static 1-to-1 means there are 2 public IPs, or NAT IPs, or external IPs. So that means 2 internal IPs, private IPs, will get translated, and first come first serve, as so there is no reservation here, right? So if like the first computer is 1.2, then 1.3, so yes, both connections translated successfully, allowed. But what about 1.4? No, there is no available IP address in the pool, so translation would never get done. So for testing purpose, and what's the status? Let me disconnect and reconnect this. Okay, so I'm back to this R2, and here we have R1 and R2. All right, so first connection, maybe for like I'm initiating connection from computer, Windows 7 computer, and also there is no translation in like firewall. So both IPs are still available. Both external IPs are available. So the first one, facebook.com. Now I should see some session here. So first 1.2 successfully mapped with 130. I think we use 130 and 131 also. And then R1 going to 28, repeat 500 packet, yes, through, and then R2 888, and no success here. Only two external IPs, so internal 2 IPs, and as I said, like first come first serve. So initial 2 connections. So I can see here 131 hitting to 12.0.1.28, like AT&T route server is a ping packet, and 130 for this 1.2. So 1.3 is like mapped with 131, and 130 is here, right? So if I just clear the connection and all sessions, and now again, and see here, once connection is cleared, then R2 is now able to reach out to 888, because IP is now available, right? So refresh this, and we can see here. So basically, in one-to-one, there is a static mapping of IP to IP. Port is not translated, but if there are 4 internal IPs, then there should be 4 external IPs also, 1:1 mapping. So that's what and we can use this type of NAT in like dealing with what do you call it, overlapping NAT scenario, wherein like if 2 sides same IP address range, 2 sides same address range, and we want to set up IPsec tunnel so that they both should communicate, site A and site B, both having overlapping addresses. Then in this type of scenario situation, what we do, we translate the /25 or /24 network range with another virtual /24 range, maybe in a static way, static manner, 1:1. So 254 IP is mapped with another pool of 254 IPs. So that is basically static NAT, but not of IP, network to network, I would say, or subnet to subnet. So we can use that. I mean, like, it's not something that can never be used. Same if you want to use other options, not used like very much, but still, let me show you. Because generally in source NAT, what we use, port address translation, or maybe this overload option, right? Wherein like we hide firewall interface IP. We do not use firewall interface IP in any NAT translation. We specify a different IP in the NAT translation. So this one, first option. So either using firewall interface IP or maybe this overload option. Generally, we see these two translation in firewall security rule, like using either this overload option if really we want to use like any virtual IP that is not assigned to firewall interface in the NAT translation, then we use this option. And if we do not have any extra IP, like for the translation, we want to use firewall external interface IP in the translation, then generally we go with the default option. Like options available here are very rarely used, in fact, because in fixed port range also, what we are going to do, fixed port range also here, the name, and you can see here like in fixed port range, it's asking to specify both external IP range and internal IP range. So if my internal IP range is 172.16.1.2 to 172.16.1. maybe 50, 2 to 50, right? And external IP range 192.168.1.170 to 192.168.1.172. So 70, 71, and 72, 3 IPs, 3 external IPs, and 2 to 50 here, approximately 48 IPs internal, including this 2, even 49. So now what happens here? A fixed port range is automatically computed. That for this, the port number that I'll be using in translation may be 10,001 to this port number, maybe 10,001 to maybe 11,000, for example, or 11,001. So 1,000 ports range reserved for one IP. Then again from 11,002 onwards, maybe to another IP, like this. So basically, this way, what happens? At least firewall knows like how many ports I can allocate for IP, in fact, and what would be the range, in fact. A range is automatically computed, but it is not very useful option, even though like we can use this, no issue at all. But fixed port range, but is something like controlling port allocation, not exactly reserving, but allocation. In fact, that if there are 50 computers and 2 or 4 public IPs are external IPs, so at least each IP should have like port numbers available that can be used in translation. It's not like if one of the computer is the top talker sending too many requests, right? And all available port numbers exhausted in doing the translation, that means this will lead to starvation for other computers. Why? Because they wouldn't be able to, like route any packet through the firewall, because firewall has already exhausted all ports in dealing with a single host device, right? Maybe a single host device used all 60,000 ports. So that's what this option is here, right? With this option, what happens? A fixed port number, a range rather, is allocated or reserved for IPs. So firewall now understand if total there are 50 internal computers and total there are 2 IPs, that means I have approximately 1,20,000 port numbers. So there should be equal division. So now divided across all 50 IPs. So that's the reason like why firewall is asking like to specify source range also, source IP range plus external range. So will this impact to our translation? No, because we will see here like a specific port number. Let me clear the session first, end all sessions, and also still there are some session because this need to be closed. Still active session and all already ended. All right, so still there are some connections and okay. And all sessions gone now, finally. Still, there are some initial messages coming from 1.2. So computers generally what they say they do, if like let's say here there is some link or maybe Windows update is running or some any other update is running. So generally DNS resolution first required, like resolving name to IP address. So and I can see here like packet hitting to 888 DNS server basically, but no worries. So now if again I initiate some traffic from here like twitter.com or maybe facebook.com, so for us like there is no like effect, there is no impact on the translation. What we have done, we have just specified internal IP ranges, right, with external IP range, just equal distribution of port numbers across all computers. So that's the reason. And here, if I see here, let me drag this source port here. And also, do we have translated port option? Where is here is the source port, NAT port, and this NSE port. Okay, so I have adjusted columns like on the left hand side, I mean my source IP, source port address, source port, and source port address. So now look at this source IP translated to 170 and port address, original port translated to 8372, then translated to 6870, translated to, and it's not very hard number, right? It's somewhere around 6,000 or 8,000 range. Okay, I can see here for 1.2 in the same range, in fact, 6 or 8,000 numbers approximately. That means internal calculation must have been done by the FortiGate firewall. What port range I can use for this first IP, like 1.2, what port range I can use for 1.3 or 1.4 or 1.5, right? So this way, so if I just hit it, then refresh. So maybe this time a port number is 10,664. 10,664 here, the source port number for this traffic. 1.3 IP is 1.70. So basically, if you and it's not static, so even like the IP can be reused. Of course, if connection is idle or terminated, then the IP can be reused. So specifying internal IP range is something like we are forcing FortiGate to perform some internal calculation for the port numbers, available port numbers for each IP, right? And what port range can be allocated. Simple. And same with the last one, in fact. Even if we go with the last option, that is a port block allocation, edit, and last option, that is get rid of fixed port range, create a new, the fourth one. I'm going to name it port block allocation, port block allocation. So we are doing it manually, right? Now, if I say like, okay, external IP is, there is only one IP, maybe 1.180 IP, or let me take two IPs, 181. So there are two internal IPs, and I don't care about the internal. Let's say on LAN side, I have total 250 computers, 250 private IPs. External side specified two IPs, right? It's not asking about the internal IP range. External IP range 2 and block size. If I go with the default selection, 128 block and blocks per user 8. User means here IP. So default is something for each IP, for each internal IP, 128 and 8. And why 128 into 8? Because default is each IP can use 8 blocks, and one block means 128 port numbers. So a single IP can use 8 blocks, and each block has 128 port numbers. So it comes to 1024, I believe, port numbers. That means we have done a reservation in, right? And what type of reservation it is? Basically, we have reserved 1024 ports per single IP address. And how many ports are there total? Approximately 60,000 ports. So if 1,000 ports I have reserved for one computer, that means this translation would support maximum 60 computers only. It's a reservation, in fact, right? So this way we can go with this port. It's a bit confusing, I understand, port block allocation, because we are doing this allocation. We have specified that each IP should have 1024 available port numbers. That means each IP, each computer can have 1024 concurrent translations. But this way, since total number of ports is equal to 60,000, and if we take it in round figure, and each IP can have 1,000 translations, so total number of translations, not translation, IPs supported here approximately 60. So that's the way how calculation is done in this port block allocation. If we want to give more number of ports per IP, so we can increase this block size. So block size can be increased. So for each IP, we are giving 8 block, and each block can have 128 port numbers. So that's what port block allocation is. Just hit down OK, use this port block allocation in policy, and done. So there are 4 different options in IP pool. And now if I go to IP pool section, so right, because even I could have created like IP pools upfront, and then I could have used those pools in the firewall policy, but no worries, there are multiple ways of doing configuration in FortiGate firewall. You don't have to stick to one or two method, like, because there are multiple ways in fact. So we can see like the pools created during like firewall policy creation. Pools, if already created, you can use them in your policy. No, one of the same thing. And here this is the reference. Yes, Derek, go ahead.
The port block allocation.
Okay.
When you assigned 128 and each of them providing 8 blocks, what are you based on? Is that a random TCP port numbers? What is it based on?
Exactly. Port numbers are random, and generally higher port numbers are used in the translation. So random, but generally we have seen in most of the firewalls that higher port numbers are generally used. But yes, random port numbers in the translation. So if we have used in this port block allocation, each by default, each block can have 128 random port numbers, any port number, but generally higher port numbers. And if we have given a single IP, a single computer, maybe IP address is 1.5. So I have given 172.16.1.5 total 8 blocks, right? So this guy like 172.16.1.5 has total 8 blocks. And in each block, there are 128 ports. That means if we compute number of ports here, that is reserved number of ports, then oops, no, please, let's go with the same. So number of ports for this guy, I mean like 172.16.1.5, how many ports reserved for this single IP. So we can do the computation this way, that 8 blocks assigned are given to 172.16.1.5 IP, and in each block there can be 128 ports, right? So if we give only one block to the computer, that means total 128 ports reserved are allocated to this machine, but total 8 blocks, so 8 into 128, that is 1024. So now 1024 ports reserved for this IP, but what would be that number? So that is computed automatically by the firewall. So maybe if just example, maybe 10,001 to maybe 11,024. Maybe firewall can start from 15,000, 13,000. We don't know really. But what we know, that 1024 ports available, reserved for single IP, right? But as we know, total ports available in NAT is approximately 60,400. So if already we have reserved 1,000 ports for single guy, so we have total 50,000 available ports. So this way there can be like 50,000 more, like 50 more computers, right? Because out of 60,000, we have allocated 1,000 ports to single IP. So now you can compute, you can calculate how many internal IPs would be supported. Understood, Derek?
Yes. Got it.
Okay. So it's about like reservation. In fact, it's about reservation. But what would be the port range? We don't have control over that, right? So that is automatically computed, but generally higher port numbers. But we really never know like the port ranges picked up automatically by the firewall. All right, so moving on to the next segment, and the next one is destination NAT. So what we want to initiate traffic in this direction from here. Let's say this is my web server. I want to access web server with his NAT IP, not with the real IP. Real IP is 172.16.1.2. I want to access this server with any virtual IP, NAT IP, maybe from this range. So what option we have in Fortigate firewall? Let me shut down these two, not required. So if like it's an internet user connected with internet, an internet user wants to access web server in my internal network, or maybe in the any other security zone like the DMZ. But private IP or real IP address is not revealed to anyone, like whoever is connected to internet. That means external user, internet user will not be knowing the real IP of the server. Maybe we have exposed or we have advertised a NAT IP, a public IP. Basically, in this lab diagram, of course, any IP we can pick from this range. So maybe 192.168.1.99, for example. So now this guy like connected with internet knows that server IP is 1.99. So we'll open the browser, type HTTP maybe colon 192.168.1.99. We know, but 1.99 is not the server IP address. So what will happen now? Request coming in like from this machine. We really don't care about the source address, what the source address, and even we never know like from which source request packet is coming from. Destination, yes, we know that. Destination 1.99. 1.99 is virtual IP, NAT IP, used in the translation. Even 1.99 IP not assigned to any interface or anywhere. So with destination NAT, what happens? Destination IP address, this IP address, translated to server real IP address. Even if required, then we can also do port translation. Let us assume my server is listening on port 8080 and the original request hits port 80. So we can also do port translation. That 8080 translated to 80 translated to 8080, or maybe vice versa, right? In both way, like we can do like translation. So this type of NAT is known as destination NAT, wherein destination IP address and if required, then destination port address are translated. Only IP or maybe IP and port both. Destination NAT, right? So how do we configure destination NAT in Fortigate firewall? Is it with the same firewall security rule or policy? No, we cannot do that. In the policy like option that we have discussed so far, we have seen like was for source NAT, not for the destination NAT. And I hope you understand objective is to access from here, from this machine, access web server, but not with its real IP, any NAT IP, right? So I've connected a computer in the same network segment. Let me close this RDP session because we want RDP session of this computer now. From this machine, we will try to access web server with its NAT IP, and we are going to use NAT IP as like 99. And we can assign IP address to this machine, any IP address from the same network range. Now, how we configure NAT then? destination NAT in Fortigate firewall. So in order to configure destination NAT, look for option here that is virtual IP, and here we see that option virtual IP. Sorry, this one virtual IP. This option, right? So with this virtual IP, we perform destination NAT. So source NAT, like we did with the security rule, security policy, right? But destination NAT from here, virtual IP. And another important point I must mention here, in destination NAT, even let us assume I've created a virtual IP object in Fortigate firewall, virtual IP, that whenever any request hits 192.168.1.99, then please translate to 172.16.1.2. Right? In virtual IP object, we mention both external IP and translated IP. So 1.99 is what? NAT IP. And 1.2 is what? Translated IP, real IP. Plus, we also create, and we would have to create firewall policy. Since we are not doing NAT inside the policy, so separate firewall security policy is required here, right? Policy that allows, that permits incoming web traffic. Objective is to access the web server. So with firewall security policy, we will have to allow HTTP traffic. That means in destination NAT, we cannot accomplish the task in single step. 2 steps are required, like creating a virtual IP object or configuring destination NAT, and then creating firewall policy to allow inbound traffic, incoming traffic. Right? There is no shortcut here. In source NAT, yes, there was a shortcut, but in destination, no. So I'm starting with the virtual IP, and it's very simple. Just click here, virtual IP. I will name it destination NAT for my web server. You can give any name, no issue, but just you should always give some meaningful name. You should always use meaningful descriptive name, right? Color, maybe even you can use different color to define the object. No, I will use blue color. Anyway, so interface, here again we have the option to mention this interface. And I know like request that would be coming from internet side would hit my external interface, that is port 3. So I can mention here port 3, and it's always a best practice. A static NAT with fully qualified domain name or IP, so IP address of course, and request overhead 99 IP, and then map to which IP address? Real IP, my server IP address 1.2. So it's very simple. NAT IP and actual IP, port number, simple. And here like we have option to specify service ports and also port forwarding. I'm going to show you that also, but for now we don't want to enable optional filters or port forwarding. I do not want to include service or port forwarding for now. Okay, so object is created, DNAT to web server. And for this object, we will have to allow web traffic. So now we will have to create a firewall policy, all right? And in firewall policy, is policy to allow inbound traffic, from inbound web traffic, right? Inbound web traffic, incoming traffic coming from WAN side. So incoming interface will be your WAN port, port 3, and what about the outgoing LAN side, port 2, right? Port 3 to port 2. Source address, really we don't know. all. What about the destination? Now this destination address should be your virtual IP object, wherein like we have specified both source and real IP and the NAT IP. So destination should be what? Destination should be object that we have just created. Which object? Virtual IP object. Sometimes what happens, immediately you might not see destination object listed over here. And if that is the case, then I'm going to tell you the shortcut the other way. So hit down, like click here, plus, and look for the object that we have just created. And this time, yes, we can see here. If we don't find, no problem, just refresh 1 or 2 times, and maybe within a minute or so, you'll see the object. And it's still not listed, then even we can go to this virtual IP, and then we can right click, and we can select the option that create policy using this object. So it's another good option. So in FortiGate firewall, there are multiple ways of performing any task. So now, but I can see here DNAT web server, and you will see like the both IPs mapped here. Always action is accept. And what about the service? I want to allow only the HTTP service. So look for HTTP service. So perfect, good to go now. Like incoming interface, outgoing interface, source address, destination should be your object that we create here, and service action is allowed. Do we have to enable source NAT? No, not required. Even if required, then you can do that, but not required because there is route for the return traffic. When this option is only required to be enabled if there is no return traffic route, if there is no route for reply packet, then generally we do this, enable this. Otherwise, no point of enabling source NAT. Source NAT is not required. Source NAT is required only if this guy like server doesn't have gateway, doesn't have a route to the source IP. Then what we do, we enable source NAT so that source IP translated with this IP. So whenever traffic hits the server, source IP address is 1.101, means now routing or gateway not required at least. So 99% of time, like internal servers like would have gateway IP address, there will be proper route, so not source NAT, enabling source NAT not required. Hit down OK. So we have completed both steps, created virtual IP and also created a rule here, incoming traffic rule. And the NAT is disabled, of course. NAT is disabled. So let's do verification. And for verification purpose, I'm going to access external computer machine, this Windows. And so this blocked. Hopefully this machine should be accessible now. I clicked twice, I believe. Earlier, like the pop-up was blocked with the firewall. So yes, I clicked twice. So this machine should have IP address from 1 and 2 range. So because we assume like device to be connected with internet, right? So what IP I want to assign to this computer? So I can assign any IP from this range, external side, 1 dot maybe what to use, maybe 177. 177. So 177 IP address assigned to this computer. So this way, this machine is now part of external like internet site. So from here, I will initiate traffic to .99, 1 and 2, 168, 1.99. And if translation is successful, then IP address will get translated to server IP address this way. That's what destination NAT is. So, okay, it's connected to internet, and already I think there is DHCP server running in my home network, a broadband router. So I believe this machine has obtained, yeah, 1.9 IP is already obtained. Anyway, you can assign IP manually, no worries, right? 9 IP automatically assigned, and but let's say I want to go with this, the same IP that I mentioned, 177. 177 mask gateway 192.168. Let me put the same IP as a gateway, and 888 or something. All right, okay, close. So it's external machine connected to external network, and from external network side, we are going to initiate web traffic to the IP specified in virtual IP object, that is 99.192.168.1.99, and if NAT is successful, then 1.99 will get translated to 172.16. Cancel this. 16.2, I believe. What is server IP? 1.2. 192.168.1.99. 1.99, even though is like just virtual IP address, not specified anywhere. 1.99 is a virtual IP. And see here, server is accessible. Web server is there is a small web page just for the testing purpose. And where is this page? Here on this server. So a single try even like destination not successful, and can we do verification from here first? Like let me show you session, and also from the log I will show you. So traffic coming from 177 and destination 199. But for a destination NAT verification, best place is to go to forward traffic section. Forward traffic section, right? Forward traffic for proper verification, and I will have to put a filter here because I can see like too many requests. So can we filter out with the basis of source address or maybe destination address? So source also, we can just type in here source IP. Where is source host name interface, and where is IP? Source city, family, hardware, interface, role, NAT IP, source port, region. And there's no option. No, not possible. Go destination. Source server or something. Source host names. Source NAT IP. What is NAT IP? This is NATed IP. Yes. And you can see here, like already, if there is a only source, I think. Yes. So source IP, I can see here, like I don't see that source IP address. So let me specify it. 192.168.1.177. I don't see any traffic here coming with this source IP. So let's try one more time. Maybe timed out, because I can see here translation happening. Get rid of the filter. So in this log section, I don't see any like hitting like 177 from outside deny policy action. I can see that.
But we were permitting IP 1.99, right?
Yes, 1.99 is the destination. Yes, 1.99 is the destination. So we can search for that also, destination 1.99. So do we have anything listed like here? I think logging option is not enabled or what, because I don't see any log, like any request packet hitting 99 even, because we have used .99 in the policy. So why we don't see any log here? But session is there. I can verify session from here, FortiView session. So source IP and destination IP and TCP port number 80. So session is created, and even is under like proper verification that we are able to access server with this IP 99 IP. And 99 IP, and this page is opening, and the page is like here on the server, backend server. But why we don't see any log? So this is the server basically. So server is like accessible from here, and even we can, if we allow RDP, then even we can take RDP of this machine also, right? From here, 1.77, we can take RDP of 1.2. That is also possible if RDP is allowed. But why we don't see any log? So logging is enabled or not? So just double check. Inbound traffic, edit. So log all sessions, because only security events logging was enabled. So probably it was the reason. All right, so again, I'm going to refresh the page with Control F5, Control F5, right? Control F5, and forward traffic with source or destination, use the filter, source or destination. We can use any filter, destination also we can take here, destination, and can we see destination here? Because generally if there is any log, then even address, we find that address here also, so we don't have to type. So still I don't see any address. And what if manually I type? No, I don't see any address like 170 or 99 destination. No, with 99 as well, there is no log here. So logs is still not coming up, and but session is there. So yeah, check one more time in session. Still session valid or deleted. So session, yes. Source 177 is perfect. 177. Destination is 99. TCP port 80. Port is 80 and source port. So I can see the session entry, but log or logging, a log option is not showing up. So can we do some other testing? Just let me initiate some other traffic that is not allowed. So not allowed, of course, ping is not allowed, for example. So if I try to ping any IP address, maybe 1.2 directly even. So just I want to check, like, is there any request like, so I tried to ping, and this time I can see here log 177, from 177 to this destination 1.2 and policy deny. So can we use this as a filter criteria? Let me check this back. Source 77, how many requests I can see? Now it's showing here. I don't know like why at that time it was not showing. So refresh again.
Can we check once again why we this IP 1.99?
Still, yes, I'm going to do that. So I have refreshed the page like multiple times, and now we are expecting more logs here. refresh there. So now there is filter in place, and refresh. So just 34 seconds, and now I can see here there is a log message coming with 177 destination, and I was interested in web traffic. So can we adjust the table? So unnecessary archive is there. I'm not interested. I'm not interested in application, result, policy ID. I'm interested in some destination or NAT. In fact, do we have some NAT option here? KLMNOPQRST, but we should have some NAT option here. And policy, parameter destination, protocol, SD-WAN, source name, source NAT IP, source port IP, source port, and also do we have, I think destination is by default selected. Destination is selected, okay. All right, so source, destination, source port, and where is destination NAT? In fact, one more field I'm looking for, destination NAT, so that we can also see like the translated. Even though if we just double click, so will show like here on the right hand side, so no need to do that all the adjustment. So source IP 1.77, source port I can see, interface I can check here, and destination IP 99, and yes, so no need to add anything. Even we can see here the NAT IP. That's what I wanted to show you, NAT IP. So destination IP 1.99 NATed to 1.2. So this way translation is done. Destination NAT, destination IP is translated. And in case if you want to do port translation also, so that is also possible. And how we can do that? Port translation. So we can go to the same option, virtual IP, under policy and object section, virtual IP, and edit the object. And on this page, we have option to mention service, that if request hitting on port 80, even you can create your own service also. So you can mention service here first, right? So it's very restrictive now. If source IP, in NAT, in fact, we have specified that NAT will be done only if destination IP is 199 and destination port number is 80. If destination IP and destination port both are matching, then only NAT will be done. And can we do a forwarding also, that if request is hitting on port 80, then that should be forwarded to 8080, or vice versa, opposite of it? Yes, we can do that. Simply just enable port forwarding, and you can mention here port number. So if let us assume my server is listening on port 8080, so now only 8080 is now, yes. So now here, like what I have specified, that if request hits 1.99 port 80, then do what? Translate 80 port to 8080 and translate IP to this IP. So this way, even we can include service, we can also do port forwarding. So destination NAT is not very complex, it's very simple. Destination NAT, source NAT, yes, a bit confusing. Too many options, one-to-one, load, overload, and all that. But in destination NAT, there is no confusion at all. Now, the last point before we just conclude today's session. How do we configure central SNAT? Destination NAT, we have the same option, the same way, but in source NAT, as we discussed in the theory, that we can configure source NAT in different way also, right? From central SNAT option. But where is central SNAT option? It's not showing here, central SNAT option, right? So for that, go to system and then settings, and enable central as NAT. Central as NAT is by default disabled, right? Because even Fortigate assume that if there is no like as such use case wherein like central as NAT is required, then you should not use this option, right? Because configuring NAT with the policy is much more simpler, easier. But in case if you are like coming from different vendor or you are doing some migration, migrating your configuration from checkpoint of Palo Alto to Fortigate using Forti converter, then central as NAT required. Turn on, apply, will give a warning message, most probably no warning message. But what happens now, NAT option, like in the security rule, wouldn't be available anymore now. Apply, applied successfully, and now I will see the option here in policy and object. I can see very central as NAT. Still, I don't see. Okay, and this is one like caveat in Fortigate, right? And I understand like what happened, what must have happened. I enable central as NAT. No error message was displayed at that time. We didn't see any error message, no warning message, but I can see central as NAT is not enabled still. And why it is so? Because there are some security rules, right? The security rule already created, and with that we cannot use central as NAT. Central as NAT can be used only if there is no policy style NAT configuration. So already there is policy style NAT configuration. Again, let me show you, right? Policy style NAT configuration in this rule, this one. See here. So like I can see here like NAT IP pool configuration already in the security policy. So as long there is a security rule with NAT traditional style, traditional or default, rather I would say, you cannot enable central as NAT. That means get rid of all the firewall security rules first and then enable central as NAT. Remove like firewall rules. Firewall rules are not automatically enabled, right? But the question here, there should have been some error message stating that sorry, you cannot enable central as NAT because there is already a firewall security rule. This is something really not very good feature in Fortigate firewall, because if we are turning on a feature from GUI mode, no error message, and we don't see any central as NAT option here still, and no error message. We know the reason that with this firewall security rule, central as NAT cannot be enabled. I'll have to delete firewall rule. But why like there is no error message? And if I try to do the same from CLI, I'm now in CLI mode of Fortigate firewall. And if I run the command config system settings, because we are dealing with system settings, right? System settings. See here, like we have tried doing the same, and then run a command set, and then question mark. Is there any option to enable? Yes, here we have central NAT. Enable and disable central NAT. What I want to show you, whenever we perform the same activity from CLI, right, and there is some issue, so generally we get an error message. They're sorry, you cannot enable this because there is some policy. But in GUI mode, as such, there was no error message. And see here, incomplete command, however. So what is complete command enable? Now let's see what message we see and look at the error message. Perfect. Cannot enable central NAT with firewall policy using IP pool. We know that, right? But there should have been some error message in GUI mode also. This is really something that really need to be fixed by FortiGate firewall.
Yeah.
Because right, you see like this. Because if I'm not aware with the fact, then what I will do, I will like multiple time I will go to then system settings and I will double check is central as NAT enabled, automatically turned off. Again I will do this, enable, apply, no error message. And it's saying like changes reflected. And if I just close this window, I will see again the same. So now we understand like the reason why it is so. Reason is what? Cannot enable central NAT with firewall policy using IP pool. That is why. So what I want to do, I want to create. Let me remove this like inbound. LAN to internet. Remove it completely. No worries. Again, if I go to either GUI or CLI mode, even from CLI mode also I can enable. And still cannot enable central NAT with firewall policy using virtual IP. Still giving the same error message, right? But there is no let me refresh one time. Now we have deleted that rule. So generally there should not be any error message now. Refresh the page and open window again, the CLI console. So config system setting and then set central as NAT enable. Still cannot enable central NAT with firewall policy using virtual IP. Okay, so now we have this option also. So just remove this also, right, from here, but we cannot remove directly. So first you'll have to remove this, because here also we'll see like a destination NAT and virtual IPs. So there will be a little change in fact. So that is why asking to delete. So best practice is always enabling central NAT option from CLI, because at least from CLI we get an error message that why central as NAT is not enabled. But in graphical user interface mode, we don't see any error message. So hopefully this time there should not be any error message, right? So central as NAT is enabled now successfully. So what we did, we previously created NAT rules, right? And now is a refresh required or not? So let's see. Refresh one more time. Now we should see central as NAT option under policy and object section. So I think it's still not reflected yet. And what if we go to again GUI mode of it, just to check that whether enable or not, tab is turned on or not. Central, what is central as NAT option? No. Let's do more time verification. Enabled. So we should see now. Yes. And how like so the issue was, of course it like takes time, but issue was previously existing NAT policies. Now here also I can see DNAT is added. However, like will not make any change. Though like if I click here, DNAT virtual IP, so you'll find the same option. The name is changed, however, destination NAT, and like some specification, but very much the same option. Type and external IP and map IP and filter and port forwarding, right? Just only like here we have nothing like different than the like old style, in fact, NAT configuration, but we have now central as NAT option. So now in order to create NAT policy, go to central NAT, and then here the same option. So I don't think I'll have to explain all again. The same option like incoming interface, but very much like we are doing in firewall security policy style. Source address, right? So you can specify your source address, destination address, all NAT, and if you want to use outgoing interface address, use outgoing. Even if you go to pool, so all four options, same options, right? If you want to create new pool, nothing different here, nothing has been changed. The way like how we create policy is different. So I want to go with NAT policy only. So NAT policy is now created. So I've successfully created a central NAT policy. Now just go to firewall policy. Now like you'll have to do both separately now, firewall and NAT policy. So create a firewall policy to LAN, to WAN, incoming interface, LAN, outgoing interface, WAN, source address. I can take here the source address, LAN address, destination. It's very much like Palo Alto firewall style. So, and here, like on this page, you don't see any NAT option, right? We are very much aware with the fact that if central as NAT is enabled, then we don't see NAT option here on the page, like from where we create firewall policy. Now hit down OK, done. So now NAT is created, central as NAT. So showing here a custom, use outgoing interface address. So it was like your central as NAT. So only like the way we create NAT rule or policy is different. Otherwise, same options, right, in source NAT and also in destination also. So same source and destination NAT, but configuration wise, yes, it is different than the policy based NAT, in fact, or firewall policy NAT. It is known as central as NAT. So that's all like about NAT. In next section, we'll start next topic. And next topic is your SSL or HTTPS inspection. And then maybe in 1 or 2 sessions, we will cover this whole profile, mainly application control, web filter. They are very simple, in fact, straightforward. So next class, day after tomorrow, and next class will be about this SSL inspection or HTTPS inspection feature in Fortigate firewall. And after this SSL and HTTPS inspection, we'll cover application filter, web filter, video filter, maybe 1 session, and then your HA and VPN part, high availability and VPN. So, and authentication. So 3 or 4 more topics based on your firewall. And once we have finished like this firewall, like NSE4, then SD-WAN is completely a separate module, NSE7. So we'll then start SD-WAN. All right, so any questions so far? Because I will end up today's session here. So because NAT topic is finished today. Derek?
I'm good.
Okay.
I'm going to read off the central NAT. I'm just a little bit confused on the central NAT, creating it. What's the purpose of the central NAT? I know the NAT, I know the destination NAT. However, why do I have to do the central NAT? What is any particular application that I need it for? I just don't know when I need it for.
Okay, so basically, first, like as I mentioned, central as NAT is not any other different type of NAT. It's just like a NAT configuration. How do we configure NAT in Fortigate? So for NAT configuration, because type of NAT is still same, source and destination NAT. In source NAT, there are multiple options, one-to-one,
Correct.
overload, all that. But how do we configure NAT in Fortigate? For that, there are two different methods. One method is like firewall policy NAT. Firewall policy NAT means like whenever we create policy, then under the policy, we enable NAT option, be that source or destination. And another way of doing NAT configuration in Fortigate is central SNAT. And configuration wise, even like the change here is only for the source NAT. So in order to configure source NAT in Fortigate, there are two different methods. We can go with either this style, or maybe we can go with this central NAT SNAT style. For destination NAT, we don't have choice, but for source NAT, we do have choice. But the next question, as you asked, like why do or when do we need a central SNAT style configuration? Why not to always use this type of configuration? Because it's only the difference that we see here is the way like how NAT is configured. Nothing different than the source and destination NAT. Yes, and that's true, 100% correct. So when do we use this configuration option? So basically, whenever we migrate configuration from Fortigate, like from any other vendor, like let's say from Palo Alto or Checkpoint to the Fortigate firewall, Fortigate. So for this migration, Fortigate has a tool known as FortiConverter. So what happens? Your Palo Alto firewall configuration is converted to Fortigate with the tool, with the software provided by Fortigate. So since in Palo Alto, we create NAT policy exactly very much like as we have here in Central SNAT. That means in Palo Alto, we create a separate rule for the NAT, like source, destination, and then translation address. So for backward compatibility, or whenever you are doing migration, so Palo Alto firewall NAT policy will be converted to Fortinet NAT policy, but in this only, Central SNAT. So you will have to enable Central SNAT in Fortigate, because Palo Alto firewall policy is exactly the same as with Central SNAT. So the question was like when do we need central SNAT style configuration or central SNAT to be enabled in Fortigate? So generally, this central SNAT you will have to enable only if you are doing any migration. You are using FortiConverter, you are migrating configuration from Palo Alto or Checkpoint to the Fortigate firewall. Then only you will have to enable central SNAT. Otherwise, in my opinion, there is no point of doing configuration in this style, because if we can do NAT configuration easily in the policy itself and per policy basis, so unnecessarily going this way is never recommended, because you'll have to create two separate policy, NAT and firewall. Make sense, Derek?
Yep, I got it.
So this option is to be enabled only if you are doing migration or something, because this provides like the same option. Like I mean, like in Central SNAT, we see like the same options like incoming, source address, destination address, NAT, a condition kind of thing. And exactly we create NAT policy in Palo Alto or Checkpoint exactly in the same way. So just to make that compatible, configuration compatible from one vendor to another vendor, a central SNAT option is here. So we need to enable that, right? That's the reason. Otherwise, no, just use like your this NAT option in the policy itself, like as we did in most of the lab scenarios. And when we will be doing the same in next class onwards, whenever we'll be creating any policy, we'll enable NAT on this page only. We are not going to use central as NAT anymore after today's session. So that's the whole purpose, right?
Okay, I got it. Great, thank you.
Okay. All right. So next class will be as per schedule, like day after tomorrow, alternate classes we are having. So in the next class, I will start with the new topic. This one, SSL inspection, and then your security profile like application control, web filter, VPN, HA, and authentication. So probably 5 to 6 classes for this firewall only. For firewall, like 5 to 6 sessions, more sessions, I mean. All right, so I'm stopping recording here.